Okay, is that better? Hopefully. Let me know if you can hear that. I think you can. It might be clipping some. Let me know if I need to turn it down. We have sound now. Outstanding. Okay, cool. What I was going to say is first, it feels kind of weird streaming because it's been so long, and I guess it's been so long that I forget to enable audio. And then otherwise, just none of these designs that I'm going to be looking at, I've looked at in the past. So I'm kind of going in blind. So if it takes a little bit to go through them, that is probably why. And I'd said hi to everyone, but of course you did not hear that. No clipping, but a background sound. How annoying is the background sound? Is it doable? And what kind of background sound is it? Oh yeah, I see it. I don't know what it is. One second. I'll see if I can figure anything out. Sounds like an AC. I don't know. I think it's something on the stream. But anyway, if it's not that big of a deal. Okay, I just turned down the gain some, so I'll just talk a little bit louder. And it shouldn't be as noticeable now if it is something background. Okay, so the first one I'm going to review is Daniel's. He has a design review thread in Discord. Does he have any additional information? Not sure. So I guess just kind of go through quickly. It's a pretty big design, so just kind of run through real fast. So we have power input coming in, which has reverse polarity, a 5 volt and a 3v3 LDO. Depending on how much current dropping from 12 to 5, that could be a lot of power that you're dissipating, but we can see input voltage monitor. I don't know what that is. Oh, just voltage dividers. So this is just kind of a personal preference. I think that's a little bit excessive abstraction to where you have a hierarchical sheet within one when it's just literally two voltage dividers. But as I always do with these, it's still so much easier to read it when it's all logical like this, so that's kind of no big deal. And I do like the way you use the buses to go from block to block. Then we have a fan driver that presumably just drives a cooling fan or something. Yeah, this is kind of a lot of abstraction, kind of annoying to go through. Fuel pump driver, and I guess Daniel, go ahead and throw in like maybe what each of these are doing. Oh, hey, Ahid, how's it going? Not, we haven't done that much. I was muted for the first like minute or two. Fuel pump driver, yeah, because Daniel, let me know what these outputs actually are. I know the glow plug driver, obviously that's the big boy. Let me know how much current that is. I think it's like 10 amps or so. Then a fan RPM, Hall effect sensor, burn chamber body temp, NeoPixel, ESP32, programming interface. So I would still, even though you're not using this for power per se, I would still pull down the CC pins with a 5.1K resistor just because some upstream ports can get kind of annoyed if it's floating. Probably doesn't matter for most cases, but just in case. And then the interface, RED, yeah, you tied those together. That's what we were saying in the Discord, because as one goes high, the other goes low, and it just flip-flops it. So that's how you normally do it. And that's just a differential to single-ended for 40 RJ45, 485. So now I'll just kind of go through quickly a few of the blocks. So reverse polarity, crowbar circuit, nothing too fancy here. Depending on the rating of the MOSFET, you don't even need this sometimes. This is just to protect the gate from overvoltage, but what I've noticed is nowadays with P-channel FETs, they're pretty high on the gate voltage, so you don't need it, but it's always nice to have, so that prevents reverse polarity. Then from here, LDO is probably going to be pretty plain. I don't know why you have this decoupling cap over here and not just right next to this. But obviously not much to that. Yeah, pretty much the same thing. I don't know why you didn't use a adjustable voltage regulator and use the same one for both, but obviously that's just personal preference. The voltage divider we've gone through. The fan driver, so fan is a 3 amp max for blowing over the heating case, fuel pump 1 amp, and glow plug is half an ohm, so that's what, 12 volts, so dang, 20 some amps, that's a lot. Yeah, heat, I was thinking the same thing. I wasn't going to mention anything with that tantalum. Since it's on the output, I would be fine with using one, even though my rule of thumb is just don't use them because they still scare me. You really should be fine as long as it's derated. The output, especially on a 3.3 rail, I don't see an issue. More so just, I don't know why you would use it for this. Normally you would use it on like the output of a buck or something to where you need a crap ton of capacitance. For just a one mic, I think you could have just used a ceramic, but it's on the input side that tantalums can be really scary. Voltage divider, so now our fan driver. So since the fan driver is 3 amps, so that's actually a decent bit. So indicator, LED. So that just drives the PWM for the LED. Daniel, what frequency are you driving the fan at? Then it goes to a MOSFET driver. That looks familiar. Pull that down. They both go to the gate. Gate, you have... I was going to give you crap if you didn't have a gate resistor, but you know better. So that looks good. Jumper to bypass if you want to drive it straight from the ESP, presumably. Aiming for 20 kilohertz. Got it. RDS on, pretty low. Gate charge 17, fairly low. So that all looks good. Too much hierarchy, yeah, that's what I was saying. I never go more than just a single layer deep because my whole theory with it is I want this top sheet essentially to look like he has it. I think that's fantastic. Have it abstracted out so you can at one sheet get a feel for what everything does. But once you go into a hierarchical sheet, I don't mind if there's a bunch of stuff in here because if I'm diving into it, I'm kind of expecting to get into the nitty-gritty. Flyback diode, he has the polyfuse on the input. Footprint, 1812. Yeah, these things get really big, especially when you get to a high enough voltage. Hierarchy is because there's a lot of repetition. Yeah, I mean, that's kind of the one reason you would do it, but still gets kind of annoying. So fan plus and minus. Unless I'm missing something here. Where do you have the other fan plus attached to? Fan plus, fan minus. That's just a really weird way to do the flyback diode, because where else is fan plus or fan minus. Oh, I see how you did it. Okay, VN goes to fan plus. Fan minus is on this side. Then you have the flybacks. Okay, yes, that looks fine. That's just kind of an odd way to do it. The way that I would normally do it is have it like across. Whoops. Have it. Oh, and you used a different minus 100 points for using a non 0.5 grid. So I would normally do it like that, and then fan minus is here, and then fan plus attaches to your 12 volt, but obviously that doesn't matter. Voltage feedback, 12 volt to 3v3. So this voltage rider, yeah, that's pretty standard. Just filtering, alternative FET. So it's the correct way. Yeah, it's correct like this. It's just kind of an odd way to do it. But yeah, that all looks for the most part fine. Strange watching my first live stream of you. I'm used to 1.5 times to 2 times speed. That is implying that I talk slow, apparently. I mean, I could talk faster, but people seem to like when it's slowed down more. I guess you're the exception. So the fuel pump drive is 1 amp. Okay, and I'm assuming, yeah, that's basically the exact same thing, so not going to go through that. Debug pins go to the outside world. Where do these go in? Here. So I'm assuming these are just for like debugging and whatnot, hence the name. But if they're going to be used at all, like in any sort of semi-permanent situation, I would have some sort of ESD protection, and that could even be just like a series resistor. But anything going straight to the microcontroller from outside is a little bit scary. So that's fine. Now the glow plug driver, we have the same thing, but a double pin on the positive and negative. Current monitoring is using a IN226, and as long as you are sizing the input side fine, nothing really there. I would say I'm not a fan of how that's separated. I would much rather have them closer, just because that's kind of off to the side and it's kind of, I don't know, odd. And on the 226, I would potentially have more than just a 0.1 microfarad, just because it is going to be more sensitive than some of your other stuff. Glow plug driver, the exact same. Yeah, so I mean, I get where you're saying that there's a lot of redundancies, but you have 3 sheets repeated. You could just have this on this, on this upper sheet, and then you're still repeating the whole thing. But yeah, I mean, other than making sure your calculations are fine for that amount of current, everything seems fine. Fan, RPM, I'm assuming you're doing that fine. There's not a whole lot there. Burn chamber body temp, that sounds intense. So that's just thermistor, that's pretty basic. Filtering looks fine. Mounting holes on there, very good. Status LED, I'm sure, is fine. 485 should be fine. I mentioned the CC pins here. This all roughly fine. That's what? Oh, USB to UART. 42. Yeah, that all seems fine. ESP32. And this is where I would get into my thing saying you need the auto programmer on there, but apparently some people don't. So, and I'm pretty sure me and you had gone through this in the past, and like multiple people in the Discord. So I guess it works. But yeah, everything on here with a quick look seems fine. I don't know if you have the PCB laid out. Maybe. Oh, yes, you do. All right. Let's put courtyard. Get rid of that. And that should be fine. It's a good way of connecting flyback across the fans. I would suggest using cheaper alternatives. For what? Those are too expensive. What are? Not sure what you're talking about. Okay, so you have 4 layers. Top layer, we have ground. Inner one, we have 12 volt. What do we have on the others? Ground and ground. So ground, 12 volt, ground, ground. And what layers are you using with traces? So you have top, you're only having traces on your 12 volt here. So how much is that splitting that up? And where is your main high current? So the glow plug is what we care about. So let's get this MOSFET. So 12 volts here. And that's your input, right? That's your input. So your main high power is this. So I get that you have it on the top layer here, your 12 volt to your glow plug, but I don't like that you have this power trace cutting through your 12 volt pour, because that kind of defeats the purpose of having that 12 volt pour on that layer, because if it isn't for that, now you get this entire pour going there. So I would definitely, yeah, you've got plenty of space. Throw that on the bottom layer. So now you have a direct shot with like a massive trace here and an entire pour. And then also with that, make sure it's good you have the 12 volt vias here, but make sure on the 12 volt inside you're also throwing them so it can get. God, those are big old resistors. What are they? Oh, they're 1206s. That's funny. But yeah, definitely have more vias here. And so you have your 12 volt rail. Then it goes to, is glow plus what you're calling the output? Yes, so glow plus and glow minus. So it goes in here, out there, and now glow plus. Nice big pour. That all looks good. And then where was your shunt on the low side? Shunt here. So low side goes across here using a Kelvin connection. That looks good. And then dump it to ground. And then ground. So yeah, kind of the same thing here. Just a quick and dirty dev board that I threw together. Yeah, you're definitely missing on the high current side a few different paths, because your ground now to get back to here basically can't go on this top. Come on. Can't go on this top pour because it's pretty much cut off. So the main path is actually from here through your thermals to this pin, which then lets it drop to one of your inner pours. So you definitely need to have a crap ton of vias all in here, like fill this up, so then that gets them on the inner layers and can dump over here. So that's on a high power PCB, that's for sure the most important thing that I would look at. And I'm not going to go into everything else. We can look at the ESP32 real quick. Oh, I like how you have the courtyard for the antenna. I normally just put that on a drawing layer. Now they have keep outs on that. So let's do. Oh, why is my paste that color? Yeah, I haven't been using KiCad 6 enough to start messing with all of the colors and everything. But I don't know why the paste is that color. In Classic, it's not supposed to be. That's really weird. Well, let me at least do another one that's not the same. Okay, there we go. So on your, yeah, so these are good. You have windowing. That's bad. You need to have the paste windowing. This definitely have it windowed. So windowing is, if you don't know, where you do the paste like a window. And the modern, most recent approach is you also window the mask. So that mask and the paste is windowed. That's recent in the last like 5 years. IPC's a draft IPC doc has started recommending that. So if you don't do it, it's fine. But you definitely need to do windowing or you're going to get the part to float up. So on here, what do we really have to worry about? I guess not really that much. I guess just the 2D coupling caps. So what is this? So that's your pull up on your enable pin. That definitely does not get priority over your decoupling caps. That's way lower priority. So this should be like over here or something and route it. Oh, I meant to do this. Route this here, however, and then route this over here and then do that so you can get these decoupling caps closer. But otherwise, I don't see a whole lot. I do have to say, I know you said quick and dirty, but yeah, you could 100% get this all. I would stick with 4 layers, but you can definitely just use 2 routing layers. It's not near dense enough to need that. But yeah, I mean, for a quick layout, I don't see anything crazy other than those high power issues. Do you need all those components up there with the sense resistors? Could you move most of those below the 12-volt fat strip and use vias for the Kelvin lines? That I did not check out that much. So glow plug here, here. So move. Do you need all those? Could you move most of those below the 12-volt fat strip and use vias for the Kelvin lines? What is the reasoning for that, Ahid? I don't see any big issue with this because what? This is analog. You want that to be short. And then SR plus minus, where's that? SR plus minus goes into here. So we're still analog. This is where the analog side ends to get the sense resistor in line with the ground output. Oh, I see what you're saying. Yeah. Yeah, I could see that. Yeah, I mean, either way, this is the area where it definitely could use some work. Either doing that or just changing this return path period. But since he said this is just kind of a quick layout, I don't think we need to go in crazy. What is a Kelvin line? So basically, if you have a... I'm trying to think what's the easiest way to draw this. 1 second. So if you have a resistor like this, and you have a trace coming in here and a trace coming out there. Let's say this is drawing like 10 amps or so. If you take your pins from here and then use your voltage change or whatever, you're going to be getting a massive voltage differential from the traces here. So instead what you do is you take it from the inner area if it's either a pad, if it's a pad in the resistor, or on some parts it'll have a separate pad for it. So there's actually no current going through these two. It's only on this side. So you'll see like Kelvin connection or Kelvin resistors like this, but they all kind of mean the same thing. Here's a good article you can show. Oh, I guess my MS Paint did not succeed enough. So Let me see. So yeah, here. Do they have a diagram? They don't have a diagram. But yeah, I mean, it's basically you don't want to be interfering with the system current because that's going to skew your measurements based on how big of the load it is, where you just want to be on the other side. So yeah, same thing. Okay, so now what browser is that? It's Vivaldi. It's based on naturally Chromium, but it has a ton of customization. It's pretty cool. I've been using it for like the past, I think, year or two. Okay, so I think unless there's anything else, any other questions or any other thoughts with this, I think that kind of wraps this one up. Overall, I mean, on a quick look, I didn't see anything crazy. Spiritual successor to the old Opera. That's kind of what it seems like. I mean, I know they have the new Opera and they have the new like GFX or the gaming browser, which supposedly is pretty cool, but I haven't used it. Yeah, I can do the 3D viewer. Oh, we don't have any 3D parts. Probably because my path on this computer isn't set up amazing. So yeah, here you can see really good what windowing is. So it does a few things. First and foremost, the one that you'll most immediately notice, if this was all paste, especially this looks like a QFN, and you put the part in, there's so much paste on that center pad, it's actually going to lift the part up, and it's not going to solder to the pads. So that's obviously a huge issue. The second problem that you have is with outgassing. So the flux is in a liquid form in the pad. So all of there's liquid or gel flux. When it heats up, it vaporizes into a gas. And if it's all one piece of paste, sometimes that can't escape and it forms like a bubble, like an air bubble, and it's called a void. So by adding those 4 windows, it gives it space for the gas to release. And you can see it on, I said paste on solder. Whoops. But you get the point. So actually here, I can pull up a picture of it. It looks pretty crazy when you see it. So yeah, so you literally get just tons and tons of bubbles here. And the big issue with it is obviously that's where the paste isn't, or the solder connection isn't made. So if this is a part where you need good heat transfer, you are not going to get good heat transfer at all. So, and here's comparing the different windowing. Oh, don't tell me. Why do you not do a full res picture? Come on, guys. So, and then this is with vacuum. So you can also do reflow in a vacuum, which helps a ton. But you can see the different, never seen that before, but how the different windows affect it. But yeah, vacuum works really well, as does nitrogen because it wets better. You were saying now they suggest solder mask to split the window. Does that cause the part to sit on the mask? I mean, I guess. I mean, not really, because the solder is going to lift it up. But I can show you thermal mask, thermal pad defined mask, I think is what it's called. Yes, so it's a draft article of 7093. So basically, this is what it looks like. So you don't have any mask or solder where you see gold. Actually, this looks easier to see. So you have your vias here for thermal reasons to connect to the other layers. And then wherever you have the solder being dispensed or being applied, that's where you don't have a solder mask. So, works pretty well. Thoughts on vias and center ground pad? Yeah, that's what this article is all about. And obviously the best is if you solid plate them, but that's really expensive. Oh yeah, so this is the article. There's a pretty good, I think it's like a IBM article. They talk about this. So 2016, so yeah, pretty new in the world of IPC. I'm trying to see if they have a picture of how it looks actually on a board to make it easier to see, because it's what we, yeah, right here. It says exactly what it looks like. So wherever you see gold, when you put on the solder paste, it'll cover that. And the reason behind it is they've just tested being better with voids and whatnot. Okay, so the next design to review, I believe, is going to be a design by Sniper 2. He sent me like 3 different ones, so I don't know which is which. Let me try this one first. It says USB adapter, so I don't actually know what that entails. Hopefully it's a little more exciting than just that, but we'll see, I guess. And I just have to do this on my other monitor because I don't know what kind of crap I have on all my past files. Okay. Yes, so it looks like it is kind of just that. But anyway, do you recommend buying the established standard or their alternative resource? It depends. I mean, I've bought, or I guess we have bought pretty much all of the main assembly standards and then a couple of the design standards, but for just doing it like hobby wise, I don't think it's worth it because they're like $1,000 each. Okay, so, and I don't think he's online right now, so I don't have a whole lot to go off of on this. Oh, he just messaged me. Never mind, I do. It is like part 1. It'll interface with 2 and 3. 2 and 3 are still works in progress. Only some of the schematic is done at the moment. All right. Sadly, I have to go to bed now. I just created my first schematic where I'd love to get some thoughts, but I have no time to upload in the next hours. Well, there's always next time, because I think I might get back into streaming a bit more. But I appreciate you tuning in, and we'll see you next time. So, yeah, the layout of this is really hard to follow. So I'm assuming this is the main input connector, 3v3 ground, TX, RX, IO0, and enable. So is that an ESP? Because he said it goes out to another board, but I don't actually know, and I can't go through all the other 3. What is this? This is a USB to UART. So D minus, D plus. That's a USB connector, and this should look more like a USB connector, in my opinion, just because, again, it's hard to follow. These go into a ESD protection IC. Nothing crazy there. This is a switch. Again, if it's a switch, draw it like a switch so it's easier to follow. This is an LDO, apparently, to go 5 volt to 3v3. What's the dropout of it? Voltage drop is between 1 volt and 1.3 volts, so you're just barely cleared using a 5 volt source. Yes, it's for ESP32. Yes, similar. Okay, so yeah, this does interface with an ESP32 then on another board. Goes D minus, D plus. Reset here. I don't know why you have a switch. Oh, the switch just goes to ground. Got it. Yeah, that looks fine. As I mention a lot, I'm a fan of a single value of decoupling cap, but that's a very controversial subject. It's supposed to be a high-speed programmer. I mean, it's high speed, but it's still using UART. And ESP32s, I think, are pretty quick to flash. Oh, to program multiple boards. Got it. Okay. But yeah, I mean, there's not a whole lot here. So I mean, it looks fine. I don't really see any issues with it. Unless if anyone got any other questions. I don't like to add extra bridges on all boards. Yeah, I mean, I don't on the designs that will do that using ESP32, but what we'll do, oh, he has a PCB with this. What we'll do is just have a external, just a cable USB to UART that will plug into our tag connect. Okay, so top, bottom. Okay, so you're gonna have a lot of ground loops here. Yeah, this'll be a pain. With so many traces, top and bottom layer, you're not having a continuous return path over like anything here. Tag connect programmer. 1 second, I will show you. It's funny, I swear I show these like every couple streams, and everyone who sees them who hasn't seen them before can't believe that they hadn't known about them. So they're like amazing to use as a programmer. You just use these 6 pins and the legs hold the programmer in, but you don't have to use the legs, so then it becomes even smaller. So they're like half the size of a standard 2.54 header 2x3. They're fantastic. So that's what we put on all of our boards. But yeah, definitely layout wise, this is, I mean, you're not dealing with anything. Yeah, pogos with guide pins, exactly. You're going to have some big issue on your returns. The only thing that really is going to matter speed wise is your USB, which luckily with that being differential pairs, it's not affected nearly as much, but you're still going over discontinuities, which you don't want to. So like there, you would much rather it be like that. And then this at least is better. But I don't know why also you're changing trace thicknesses. That's a big no-no with differential pairs, because you're not even like attempting to control the impedance there. We've been looking into edge connectors recently. I'm expecting my first boards. Yeah, edge connectors also are great. Tag Connect has some also. I believe, at least. I thought they did. Maybe not. Sniper says, I tried to get 90 ohm. I was close, 100-ish. Yeah, but that's not the point. You have 2 different trace widths. So they're not going to be the same. So whatever is here is going to be different than that. And you would rather them be like the wrong controlled impedance than be 2 different controlled impedances. But USB 2.0, to be honest, I will never use like actual controlled impedance by the fab. I'll just do the best that we can because it's really not that high speed of a interface. Is there a Tag Connect KiCad lib? I'm almost positive they include them on their website, so you can grab them from there. Our problem is we have a board running MicroPython with a large library. Takes like... Oh, you don't have to. That's what I said with the legs. You don't have to hold them in. So, do I have a... I usually have one here. No, I guess they're all out back. So you see these little legs? Those right there, the little nylon nubs, they clip into these outer holes. So if you get the ones with the holes, it grabs them in. If you get it without the holes, then you have to hold it. So it gives you the best of both worlds. Those legs look interesting, but a bit pricey. Oh yeah, they're way overpriced. They're like $30 or something for a single cable, which is really funny. But it's not like you use them or it's not like you're like using them on a product that's sold. They stay in house, so they're not that big of a deal. Okay, so now I actually only have one more, I think, to review, but it's likely quite interesting. No, I have two more, I think, to look at. Never mind. 1 second. One of them is going to be pretty interesting. Actually, very, like, applicable, I would say. So this apparently is a single board computer for some sort of network interface. He didn't give me much information here, which is kind of a shame because I'm gonna need some more info. Hopefully he's still watching the stream. It's Robin Nolajic. Nolajic. Oh, he did. Never mind. It's a small Linux computer using an all-winner S3 SoC, which has 128 megabyte DDR3 built in. I want to use it to connect different amateur radio transceivers together via the internet. Besides Ethernet, I put in a lot of different interfaces: USB, 3v3, UART, 232, 485, some GPIOs. I'm particularly interested in the power supply and input filter. And I said that this is pretty applicable because that's something that I might do some streams or a video on, is building single board computers. So USB 2.0 is like, don't worry. Yeah, as long as it's not some crazy long trace. I mean, even USB 3.0, I've really never had that big of an issue, but your mileage may vary. Okay, so first thing, this is, I think, the worst way to use hierarchical sheets because I have absolutely no way of telling what's going on here. I just know that there's some stuff in here. So either don't use hierarchical sheets or do them like Daniel did, where you can see the connections. On small boards, I will not use hierarchical sheets. On a board like this, I would do it how Daniel did. Okay, so the input filter, we have any experience with like FPGAs or FPGAs? Absolutely zero experience. I was watching, and I think Ahid had also been talking about this. There was a really cool series going on with DigiKey, like an intro to FPGAs that I thought was really cool. I wish, like, as a company, we had the ability to do FPGA work. Like, maybe in the future I would bring someone in who can, because they can just be so freaking useful. But I have absolutely no experience. What was the grid spacing? 1.27 millimeter or mils. Oh, you did the same here, or I didn't change it back. So that's 50 mils or 1.27 millimeters. So you have two TVS diodes, 10 mic, 10 mic, 100 nanofarad, 100 nano, 10 mics, 220. So he said without filtering it, that, or without simulating it, if I thought it looked fine. So two TVS diodes here unless you're specifically doing it because you're expecting to need the extra power dissipation from the second one, this is kind of redundant. What I would rather do is size the one which you feel comfortable with, and then I would put the second one over here to where there's some added resistance and inductance on it, so it actually is a different area that it's protecting. Obviously, if there's a big spike, they're both going to get hit, but it just spreads it around. As for otherwise, does it look good for a pi filter? I guess. I mean, without simulating and knowing what the rest of the loads are, it looks fine. 470 nanohenry with 220 microfarad. I don't know what your transient loads are, but seems fine to me. SoC power. I have 2 power input points on the PCB on different sites. So these are physically different locations on the board. Fantastic. That also would make sense, but I still would have to then say, and I know you said that the schematic was messy. I definitely would show that on the schematic that they're in different areas, so someone who doesn't know the design like me can actually tell what's going on. But yeah, I mean that looks fine. The one thing that you can do is add, you might have some ringing because you've only got one electrolytic here to damp it. So you could put like on one of your 10 microfarads, like a 1 ohm resistor, and then either test it and populate it, or you don't have to populate it and just short it across. But that's the only big issue I could see here if something excites where that resonance point is. So SoC power, what is this? Wait. Oh, this is the unit. Oh my gosh, you split that into a lot of units. I've never seen a single part be split that much. Is that really? That's insane. Yeah, I don't know if you made that part, but I would not split it that much. That's a pain. Hello, as a complete new person to design a schematic, what would be some good literature to do with? Remind me at the end of the stream. I'll dig up. I made a Reddit post or a comment, and I listed like 5 different things for a question like that, and I can go through it. The first one is Dave at EEV blog. He wrote a PDF like years ago, and I think it's a really good start. So power input here. Oh, if these are all different pins, you are way, way underdoing the decoupling caps. If these are all physical pins, which I'm going to go out on a limb and say they are, each one of them, EV blog has a pretty good video on it. Yeah, then that also. So yeah, these are all different pins. So yeah, you need way more decoupling. And 0603s. Okay. Yeah, I mean, you're in the world of MPUs here. So you're kind of going to want to be using 0402s, if possible 0201s, and potentially be putting the decoupling caps underneath the actual part. So like your decoupling caps are under. And now I'm assuming I can tell why you're only using this many, because you don't have physical space to put them all. That's because traditionally, like I said, they go directly under the part. As for if it'll make a difference, I don't know. Me personally, I don't have experience with all-winter parts, but might need VN pad. I would avoid that at all costs. We just did a design with 0.5 millimeter pitch on a BGA, and we had to go down all the way to 3 mil, 3 mil track spacing and width, but we were able to get it across. We were able to do it, and I don't know what the pitch here is, but you kind of want to avoid that at all cost if possible. Why is it not snapping? Okay. I don't understand why it's not snapping on anything. Pretty sure I have it set to, at least it should be. Oh. Apparently not. Okay, now it should snap. Okay, so you have 0.65 and 0.5. So yeah, the 0.5, that's where it would get tough, but it seems like you did fine. The points are not, yeah, that's fine. It snaps to it based on that. So that's a big issue I see right off the bat. If it'll affect it again, I don't know. I'm sure you can probably get away with it. I don't know how the all winners are, but you're definitely going to be violating how they recommend it because you want to have one cap per. Step down here. You definitely are going to need some more input ceramics, I would assume, or you're going to get a ton of noise on this line. That's a very interesting pull-up value, too. I'm guessing because you had it elsewhere. Feedback, 27.4. I'm guessing you did that to be more specific with the voltage. Step down here. And just as an FYI for people who don't understand this, one of the hardest things about doing a MPU design, so a microprocessor, is the power management. So ideally you can get an IC that handles the power conversion all on one part. But if you can't, chip shortage, you have to do crap like this. So the design we're working on right now that uses a STM microprocessor, I think we're literally using like 4 or 5 regulators because everything's at a different voltage. So that's to be expected. But yeah, other than what I said, potentially some more ceramics, I'm obviously not going to go through. That is a really big inductor. I don't know. Is this a simple switcher? No. 500 kilohertz switching frequency and you're using a 22 microhenry inductor. Something doesn't seem right here. That's really big. These all are. Not these. But yeah, something doesn't seem right there. You should not need that big of an inductor. What is a good size inductor? I mean, it's not like what is a good size. It's just what's proper for this. A 22 microhenry, that's something you would use with like a simple switcher, like a 250 kilohertz. And if you're stepping down from a higher voltage, I would expect. Again, it's hard to just ballpark switching regulators. You really have to start doing calculations and stuff on them, which I'm not going to go into here. This is all just connections, the clock. Yeah, the way you broke this up into units is, I'm not a huge fan because it's just hard to tell what's actually on the microprocessor. And when I say stuff like that, that's 100% personal preference. It makes no difference. If you like it like this, by all means do it. I'm just saying, me personally, I don't see diode in DC converter sections. I mean, it could be internal. Oops. Yeah, well, depending if it's asynchronous or synchronous, all of that can be internal. It depends on what is actually on here. Do I still have the data sheet up? Yeah, so it is synchronous. So the FETs are internal. So yeah, here's the block diagram. So we've got the high side FET and then the low side FET right here. So it's built in. Sometimes they'll be external, sometimes they'll be internal. Doesn't matter. I suppose the datasheet had it cut up into sections. Yeah, but that's way too many. So give me 1 second. I can't show you any of this design, but I can at least show you the symbol that we're using and show you how I like to do it. Okay, so this is for an STM32MP1. So we have one block that has just the power side. So all of the VSSs are obviously tied to ground. The VDD core is whatever the core voltage is, which is 1.252 volts. VDD, which is 3.3 volts or 1.8 volts. The internal regulators for the internal components, and then a second block which has a chunk of logic pins, another one which has all the DDR memory, and then the last one which has another chunk of pins. The key here is they're actual like large chunks and not just every single interface broken out. Again, 100% personal preference. If you like this better, by all means do it. Which would make sense if you're doing the schematic focusing on one block at a time. Yeah, either or. Ethernet, we have... Because the problem is I'm having to keep clicking these to make sure it's actually on the microprocessor. So this is the Ethernet side. So I guess it has a built-in PHY, which is nice. The STM doesn't. So Ethernet, whoops, LEDs for link, all looks mostly fine. I mean, no ESD protection here, which Ethernet, especially because it's coming from a long distance, I would definitely like to see some ESD protection on it. So that I think's lacking. LEDs or LEDs. I don't really know what this is. Just some connectors. SD card. Just an SD card. Again, ESD protection could be nice because there's a lot of metal here when someone inserts it. And to be clear, like going through this is by no means like any sort of actual review here. There's just way too much stuff here. So if you guys or anyone has any like actual questions on any of this stuff, let me know. How hard is it to start a PCB design and assembly company? Let's say harder than making a cup of coffee, but easier than trying to land somebody on the moon. So it's somewhere in between there. But did you have any advice on the high side PMOS driver usage? The VGS of the FET I chose is plus minus 12 volts, but if the source is higher than 12 volts, it means that 0 volts would be more than the VGS max. I don't remember exactly how that was set up. I can go back to it later. Just remind me. Hardest part is finding the right clients. Yeah, that's for sure the hardest. And even like us, I mean, we're now pretty established since, 2017. It's still crazy how, like, up and down, peak and valley. Like, we're super busy right now, but, like, Q3, Q4 of last year was, like, really slow. And there's just, like, no rhyme or reason to it. I mean, obviously COVID, but... UART enabled, 3v3 UART, load enable single wire bidirectional UART. I'm not going to go through all that. Do you have an example part handy for ESD protection? No, but I guess that could be, since I have mentioned it a couple times. Whoops. Can kind of go through how I would actually find one. So the SD card is going to be pretty simple because depending on if it's SDIO or SPI, it depends on the capacitance. So let's try SD card. OMG, totally agree with how... yeah, exactly. So basically, the name of the game with TVS diodes, why use a diode over a voltage divider for PMOS, gate protection, the case for the supply voltage? I mean, normally you would do both. I mean, there's no reason you can't have both, and just make sure you have a resistor on the TVS side so it doesn't burn it up. But on the ESD side, as the whole entity or the big name of the game is, the higher the capacitance that is on that ESD diode typically means the more it'll protect it. So if you're doing like a general purpose ESD diode on like a slow interface, you can get away with a big old beefy ESD diode that has a ton of capacitance. The higher speed you go, you can't use a higher capacitance or a high capacitance TVS diode. So it's kind of weighing the options of the highest capacitance you can use while still keeping a data rate that you need for your interface. What sort of ESD would have saved your computer from the nearby transformer explosion? I have no idea because my UPS certainly didn't, and it should have. I use a dedicated SD card. I've used an E-clamp, micro SD. One of the LEDs was upside down. Whoops. Right there on the webpage, I just got started as transitioning to general electronics and finding consistent business is hard. Yeah, it takes a while. So what I will do, so I look up an SD card protection. So I will go to a product that is billed as a ESD protection, and I look at what the capacitance is, 10 picofarad. So that means just a super quick search. Now I know that for a TVS diode for my SD card, I want to look for something that is lower than 10 picofarad. There will also be for like USB, I'm sure for Ethernet and like HDMI, you can look at the official standard that they will say, and they'll give you specs for the bus capacitance for each line. And if that's the case, you make sure you follow it. So depending on if we're doing SPI or SDIO, so he's using SDIO, it looks like data, yep, so that's 1, 2, 3, 4, 5. So we need a 5-pin unidirectional in stock. By the way, some ESD protection is symmetrical, so protects. No. That is a big misconception, but I'm really glad you asked that. So I will show you why that is not the case and what a bidirectional versus unidirectional actually is. And I'm not calling you out on that. That's probably what the majority of people think of when they see something like that, but it's not actually the case. So you look at capacitance. So now you can go to anything that's below 10 picofarad, and there's not that much thanks to the chip shortage. But you can just filter it and then go from there for 5-line. And then also you can see some that are specific to HDMI or Ethernet or whatever you're doing, and then just pick from there. But like everything else, it's basically going to be what's in stock, and that is the gist of it. So as for the Feldstad, I always spell it wrong. So I don't know if they're going to have, there was an article on this, unidirectional versus bidirectional TVS. I think there was an article that I shared a while ago. Yes, this is it. Okay, so keep in mind, well, you stopped on the ESD protection series, so I blame you. Yeah, true, I know, I need to get back at that. So basically what you have to keep in mind is a TVS diode is simply a Zener diode with slightly different characteristics. What those characteristics are, it doesn't really matter for this. But remember, they're just a Zener diode. So if the voltage from the cathode to the anode exceeds its breakdown voltage, it conducts. So if you are past here on the reverse bias, it conducts. Also keep in mind, it's a diode. So if you flip it and the voltage on the anode exceeds the forward voltage of the diode, it conducts right here. So you have a working range, which is from 0 volts up to whatever its reverse, up to whatever its breakdown voltage is. There is a little bit on the negative side, but you just assume it's 0. So if you have just a standard signal, and I'll show you what I mean by standard, anything that's just a normal communication bus or normal IO line, you always use a unidirectional TVS diode. A bidirectional is useless. The only time you use a bidirectional if it is a signal that needs to be positive and negative, either a differential signal or something like an H bridge that swings from positive to negative on that rail. So in this case, like plus or minus 12 volts, if you were using a H bridge that swings from 12 volts to negative 12 volts and you used a unidirectional, you would get in this area and it would conduct and burn this up. So you use a bidirectional that gives you negative 12 volts to 12 volts, and if it goes past that, then it conducts. So yes, I mean, I would say the vast majority of people, when they start using TVS diodes, they think you need to use a bidirectional, but the easiest way is just remember, it is just a Zener diode. That's it. Zener diode is still a diode, it just can conduct in the opposite direction. So hopefully that answers your question. What's in stock and then you design it and then it's out of stock? Oh, for sure. So basically all of our contracts now, we have to have the client buy the parts up front, basically before we've even, like, in some cases, even started doing the schematic, and almost always doing the PCB design, because if not, they're always going to be out of stock. I've been buying the parts and then finalize. Yeah, that's what we do. Sounds like the right thing to do, but it's difficult during prototyping. It is, but you don't have a choice. And it's like, that's why last year was so hard for us, because it's like a lot of clients wouldn't do it, but it's like, I'm sorry, like, I'm not going to design a board, or you're not going to like it when I design a board and we can't even build a single unit. Thanks, Sensei. So I did answer your question. Fantastic. Can you review my design on Easy EDA? Just send PDFs of it. How do your clients respond to that? I mean, it depends, because they don't have a choice. It's not like they're going to go to another design shop and they're magically going to say, oh yeah, there's no parts issue. So it's either they want the design they want the design to happen and they're willing to pay up front, or they're not. I mean, there's really no in between. How long will the parts shortage last? I don't know, man. I think it's going to start getting better end of 2023, but I don't think it's ever going to get back to how it was, just because there's too much money being made by parts brokers that they just buy up all the stock. I don't think it's the new normal, but I think it's never going to get back to how it was. So I think it's going to be a little bit of an in-between. Hopefully it'll get back, but who knows. Okay, so back to this. I think I was on here, right? No. Next one. Also, that TVS would work for both negative and positive static. I understood the bio. Yeah, that's what I was getting at. So this is the line that you're protecting with a unidirectional. So this is where your normal signal is 0 volts to, say, 5 volts, 0 volts to 12 volts. If you have a positive spike, it conducts. If you have a negative spike, it conducts. It either conducts in the opposite direction when it breaks down on the reverse side, or it just acts like a diode and conducts that way. Depends. If the industry overspends on new fab, we might get a surplus, but due time, the demand will certainly catch up. Yeah, but what they're not reporting on is it's not a supply issue anymore. It's parts brokers realizing now that they can make money hand over fist just by buying out all of the stock that's there. It's essentially becoming the diamond industry. And I don't want to get too into that, but if you look on Octopart enough and you look at different high demand parts, you can prove it in like 20 seconds that when a big stock of DigiKey goes up, it'll go away within like a week, but the overall industry stock doesn't decrease. It just gets posted on third-party distributors. So third-party distributors buy all the stock on DigiKey and then relist it for twice as much, which is just scum. So yeah, I don't think it really is even a supply issue right now. Right now. Okay, so UART, this enables. Don't exactly know what's going on here, but that's fine. 485. So yeah, here he ties this in to flip the direction. GPIO in. So there, that's to flip-flop. Wouldn't DigiKey make more money by not selling in bulk then? No, when they get 100,000 parts and they know they're going to be selling them at the max price break. ESD protection for the UART. I love how you have ESD protection for UART and not some of the other stuff. But I digress. And then back to the ESD debate or the ESD discussion. This is another way you can do it. These are typically Schottky diodes, so they're a lower breakdown or they're a lower forward voltage. And this time you do need them on the high side and the low side, but this essentially acts exactly as if it was a single unidirectional TVS or a Zener diode again. They're essentially the same thing. Search for logic gates yesterday. I thought JLP's search engine was broken. Yeah, it sucks. So here's RS-232. Looks fine. Again, I can't go through every single thing here. I only used if S3 internal codec, so will probably be removed. So yeah, then I won't go through that. So yeah, basically, oh, then I can look at the PCB. So yeah, here's a tag connect. So again, yeah, they're pretty common. Okay, so let's see what we have here. So what is this? This is... How did I not see that? Oh, it was on the other side. Oh, yeah, you don't have... Yeah, so I don't know if you've built this yet, but you need decoupling caps, man. I mean, you have one here, but that's not near enough. You want to have one per power and ground pair. So ideally, you would do something like this. So in an ideal world, you would have an 0201 on the opposite side. Oh, come on. You would have an 0201 on the back side here under every power and ground pair with the shortest trace you can here. If not, because I know 0201s are where it does start to get tough hand soldering, which is fine. So at minimum, I would try to use 0402s, and you're almost going to have to put them on the backside here. This is one of the things that's just a pain with BGAs, but sometimes you don't have a choice because assuming this is, the courtyard, if you were to put all the decoupling caps here, it's just too far away. So can this design work? Sure, but the decoupling scares me. So I always use that to recheck at LC. Okay, that's more talk about the parts. Okay, so what do we have routed here? A1. Oh, so that's the eMMC. Got it. Oh, yeah, obviously. eMMC needs... Yeah, I guess some of it is length matched that aggressively. I don't think it's going to be super fast to where it requires it that crazy. But, of course, the more you can length match the bits, the better you are. And I'm sure he's following the recommendation on that. And everything looks pretty spot on, so good job there. And what I'm looking at is net length down here. He matched them all to 25 millimeters. They're all pretty spot on, so that looks good. Now on here, I'm guessing this is length matching for the Ethernet. Whoops. Into, oh, SD card? Yeah, you definitely don't need a length match for an SD card. Have you ever run into problems with decoupling? I mean, me personally, not really, because I will always go overboard. But I mean, for sure, that's like one of the biggest issues, especially when you get into this realm. And when I say you don't have to length match, it's not like it's gonna hurt anything. It's better if they're all matched. It's just it's not fast enough to where it makes a big difference. Now let me check stack up. I didn't do that already. So top layer we have. Top layer is ground. Inner one. We have, whoops. Inner layer and bottom is ground. Now what is inner 2? Inner 2 is 3v3. So ground, ground, 3v3, ground. Kind of an odd stack up. I mean, the same one that Daniel used, but Daniel's was for the high power rail. So top you're using as a, what's up with the, why is the ground not all the way through? Oh, you're using this as your chassis ground. Got it. Why not make them from transistors? Well, it's a few gates. I don't, oh, you're talking about someone else. So this is something I really wish I had a better thing on. So something I really want to work on the EMC series and to start doing more on the ESD side is to start doing tests on chassis grounding, because what you are doing is having all the chassis on the outside grounded in a like a moat out here, and half of the experts you talk to say that's the way to do it, half of the experts say that's a horrible way to do it. And I really want to do some tests, so I'm not really going to comment on that too much. Me personally, as with analog and digital grounds and everything, tie everything to the same ground and call it a day. But I'm not saying that there's not advantages here. I just don't know enough certainty with that. So that's your routing plane. So everything on the top layer is referenced to basically a solid ground plane, so that's fantastic. So all of your high speed stuff is on that top layer, it looks like. Do you dive down? Okay, you do dive down to here, which is still referenced, so fantastic. So what I'm looking at when I say this is your high speed signal. So right now he has I guess I can just use, so he has his top, let me draw this out. So basically his top pour, let me do colors. Top, then he has a space, and what's the next color? Oh, it's red, thin green. Oh, come on. Oh, MS Paint. And bottom is blue. I really need to figure out my colors here. Okay, so, and you're going to see a disadvantage here of using a 4-layer board with something like this that is so high speed. So basically he has his top pour is his main signal layer. This is ground. This is 3v3. and this is signal. So notice how there's a really big space here. That's where the core of the board is. So when he's routing on here, everything is nicely referenced to this ground plane. That's absolute best case scenario. When he jumps to a via, so basically on this trace, and these are single-ended traces, which means since they're not differential, they are literally directly referenced to that ground plane, which means it's way, way, way more important to do these well compared to a differential pair. Differential pairs are easy because they are tied to each other. So, whoops. So he has all of this, it's perfectly referenced. Now he has to use a via, which drops him down here. The good thing is he keeps the same reference plane. The problem is this distance is like 5 times as far. So the impedance from here to here is not even remotely the same. So if he were to do this, bottom is ground only, inner 2 is signal and power. Oh, yes, that's what I meant. Ignore me. I didn't mean to have that be signal. I meant that to be ground. Like that. So, and this is just a limitation of a 4-layer board. Whenever he has to drop to a via, it sucks with how the reference plane is. So in an ideal world, and I'm not going to do all the colors here because that took a while. In an ideal world, you would want to use a 6-layer board that has a stack up like this. You don't switch reference planes in that you decide it. It's where the lowest impedance is for the return current. So it's whenever you have a via. So basically if we were doing this design, we would start routing this, really not overly caring about how many layers we have. But once we get to this and we see that we are dropping to an inner layer for this routing, we would immediately switch to a 6-layer board, because with this stack up, when you have a trace that is here, it is referencing this plane. Now we have a via, and I know I'm drawing it as a blind via, but it doesn't matter. Now the trace is here, it's referencing that same plane. So the only discontinuity you get is right here. Everything else stays the exact same. So if you do a controlled impedance layout and you send it to the fab, you can tell them you want to have 90 ohms or 50 ohms or whatever it is, single-ended impedance from the top layer to inner 1, inner 2, to inner 1. So all of the impedances between these with whatever trace thickness will be the same. Of course, price constraints and everything make it so it sometimes can't be. eMMC, this shouldn't be super fast. It's just flash memory, so I'm assuming that'll be fine. The SD card will definitely be fine. If this had like some DRAM or it had DDR memory for sure, then this absolutely would be an issue, and you would want to have at least a 6-layer board. But all things considered, with the constraints he had here, I think that's about as good as he can get, especially because he made sure on these traces to not have them be on inner 1. So he does have a really, really good plane here that they're referenced. So, good idea. Oh, for swapping those out, yep. So that all looks fine, as good as you can get. So the reference ground is 5 times further, so impedance would be difficult. Can maybe he make the traces wider? No, not that much. You don't have that much leeway. I mean, they would have to be like insane. Because keep in mind also, with single-ended traces, all you can control is the width. That's another reason why differential pairs are so easy, is because you can control the trace width and the spacing. So you have 2 variables to change, not just one. So I guess now probably the next thing to look at is probably the input side, just to kind of see how this looks, because he said it came in from two places. So VCC comes in here. So it comes in from the other side of the board. Yeah, I'm fine with how you did that. I would probably add some caps over here just with that TVS diode. And then also I like to have an input fuse here just because if there is a big transient and this starts to conduct a lot, it'll trip the fuse instead of catching this on fire. As a side note, when my computers blew up like a couple months ago, I had to salvage the hard drives. I took them apart. Every single one of the TVS diodes was dead shorted to ground, and it blew the input fuse. So it did exactly what I said. Would putting 4 RPi CM4 modules on a board require 6 layers? I have absolutely no idea. It would depend on what you're drawing off of there, because you could use HDMI and Ethernet and stuff, which are pretty fast. So potentially. We have a design we did with a single CM4, but you better have them already purchased. They're completely out of stock everywhere. And we did a 6 layer stack up, but that was mainly because it was talking to an STM32 and it was using DRAM, which was a bit of a pain. But yeah, how you have it come across here, that's fine with me. I don't see any issues. Then you have your caps here. You have your, where's your inductor? There's your inductor right here. Boom, boom, boom. Then it goes to your cap, and then this is your working power rail. Everything there looks good. All right, give me a couple minutes. I'm gonna go to the bathroom, and then I'll finish up looking at probably some of the bucks, and then I think I have 1 or 2 more layouts or designs to review, and we can jump to those. So yeah, I'll be right back. My bad. My bad. All right, I'll start that again. So, power coming in here. The first main loop is here, which looks fantastic. Can't get much smaller than that. Then the next loop with the switching node, which is here. And the inductor, this is the problem with the inductor being so massive. It just increases your loop. So I would definitely do some calculations and try to use a smaller inductor just because that's a pain in the butt. But layout looks good. Layout here is identical. And then I think we just have one other buck. And these two are going to be probably identical. So our jumper comes in here. Our main loop looks okay. Oh, yeah, you've only got 2 caps. Yeah, so this is where I would have a little bit more input capacitance, but looks fine. Inductor, output that loop. That's a much better loop just because of how much smaller physically this inductor is. But yeah, again, this is obviously a very intricate layout. I'm not going to go into full detail with it just because there's not enough time. But definitely for a 4-layer board, other than your decoupling on the 2 BGAs, looks really good. I think you did a really good job. I would say number 1 improvement, decoupling for these. Second improvement would probably be, if not the same with this, double-sided to get them under there. And then third would be going to a 6-layer board, which might not be possible. And then after that, just little stuff like don't use such massive inductors and stuff like that. But yeah, really, really good job. Okay, now let me grab the next, and the next one is by Jeff. He is a patron. How do you determine input or output capacitances? You come up with a rule of thumb that you think should be enough, and then you double it. The only real drawback is if you have an inductor in series like he does on the Pi filter, you can get ringing. And as long as you have something that damps it, you'll be fine. But that's normally something you get by just testing. Give me a second here. There's a couple files. Okay, got those. And then he gave me a ton of notes with it, which is awesome. Use the one with driver in the name. Got it. That is what I was planning on opening first. Where'd it go? Oh man, when you extract it to the wrong spot. Okay, well at least we got it. Okay, there we go. Oh no. We're missing a sheet. Hopefully that's okay. Okay, so I just did the second spin but haven't assembled them. The archive with drivers, what I'd like you to look at, but added the ring case. The respin is added an input bypass modification. Per your video, don't make this mistake when designing lithium-ion battery circuits. A review of the schematic would be helpful, but my primary interest lies in your thoughts regarding the PCB layout. I decided to try a 2-layer design with this top layer being ground with essential traces and the remaining traces on the bottom. My brass board prototype had an issue with radiated emissions. My first PCB spin seemed to eliminate that. A comparison with my spectrum analyzer and E-field probe showed a drastic reduction with the formal PCB. They're relative and not calibrated. So, just the title sheet block. Okay, cool. I've made the following: one parachuted cable. Okay, cool. So then, Jeff, just as a confirmation, the gist of this is a battery-powered LED driver. That's the gist of it, right? I'm assuming. So we have USB micro going in. So then this is what I was saying on the last layout. What I would do is move this fuse here and move the TVS diode there. Because right now, if you happen to have a big transient, or if somehow some idiot finds a way to use like a 10-volt powered USB connector, it's going to burn this up. Worst case, catch it on fire really bad. If you have the fuse in here, it's just going to blow the fuse, and it acts as reverse polarity protection. So by just swapping that fuse, you get a ton of added protection. Battery charger here, status, VBAT here to the power control, VBus fused. So charger, the battery is out here, VBus. Without looking up all of these, I guess just this part, it looks fine here. And since he's tested functionality, I'm assuming that's good. LED driver. So I think you mentioned this, an 11-inch long. Yeah, so your big issue here, because Jeff was saying he had issues with radiated emissions, is he is using a boost LED driver. And that is the exact opposite of a buck. So basically the noise is on the output side, and he has it going to a cable, which is, for obvious reasons, really bad. But sometimes you don't have a choice. So definitely using a shielded cable. If possible, use a 360-degree shielded cable. And that should help minimizing the length of it. You could potentially put some ferrites on here to help get any of the real high frequency noise or a common mode choke. But yeah, this is always going to be an issue when you have a wire on the output side. Okay, so get rid of the silk screen. So the first thing off the bat, I always like to have a ground pour on both layers regardless. I know you're using it just as a routing layer on the bottom, but it's never going to hurt anything to have it on both sides and then just stitch them together with vias. So, what did he say? PCB with both top layers. Okay, so yeah, most interested in the PCB layout. So EMC wise, you really don't have any potential issues with this stuff that I can see. Or with this, it's really just going to be the driver, I think. So we have power coming in here. Is there bulk capacitance anywhere on the output? Fair play. Yeah, I would add some extra capacitance out. Before I say that, what kind of actual driver is this? Is this like a true analog, or is it a PWM? LED dimming can be done by using a DC voltage logic signal. Is it? I've heard that a copper pour isn't always a good idea if you don't have a reason for it. So that's one of those things, kind of like the grounding for chassis, that everybody has an opinion. I look at it the same way as analog and digital grounds. Are there situations to where having them separate can be helpful? Sure. Is that the norm? No. So adding a copper port everywhere and tying them together in the vast majority of times is going to be better than not. Are there cases where it can hurt? Sure, but they're few and far between. So yeah, I just want to see how it's actually controlling the current on the output side. LED current V out, so it is PWMing on the output side. The LED current is repetitively turned on and off so that the average current is proportional to the duty cycle. So, Jeff, another thing that could potentially help is if you are using like a true analog driver on the output, so it's not PWMing the LEDs on and off. Oh, it lets you do it on... The LED current can be dimmed. So yeah, that could be an option. Because you don't want to have that aggressive PWM on the output side. It's funny how there's so many contradictions. That's why I did the EMC for Everyone series, because it's like, it is kind of obnoxious how many different things are. What was I going to search? Oh, yeah, so it doesn't state what is on the output side for capacitance. That's something I would probably have a spot to populate and see what it does, because you have an issue. Here's where, again, like ringing could be an issue, or if you have a big electrolytic, it could screw up the driver because it's not expecting there to be that much of a capacitive load, because it's meant to drive LEDs, obviously. But okay, so we have our input cap here, then our inductor is here. That's an obnoxious inductor. What if you did something like this? Whoops. Auto placement. Let's do 45. Yeah, I don't like this inductor, how they're on opposite corners, because if you had it where the pad was all on this side and all on that side, you could totally shorten that loop. But with the inductor how it is, that's probably the best placement. With the diode here, I'm assuming, and just as a forewarning, I don't use boost regulators a ton. Obviously, I still use them, but I'm not near as, like, experienced with them as I am with bucks. Close switch. So I'm guessing, actually, they're going to want the inductor to have priority over the diode, because that's your first loop. Your second loop has the diode and the inductor. Thicker lines. Yeah, so what I just said is true. Oh, they're using the same weird inductor. Go figure. So they would rather have the inductor be close at the expense of the diode being a little bit farther away. So you would probably want to move this like this, and then your switch node do something like this, and I know I'm over the board, so maybe move this entire thing over this way to give yourself some extra space. Because again, the name of the game is wherever your switching node is, you want to minimize that loop area. But to be fair, since your node also is going, your output is also leaving the board, that's going to be a bigger issue. Whoa, why do you have so many outputs here? And what is this? Brightness control and under voltage monitor. Under voltage, internal to the microcontroller. White LEDs are shut off. Sure. I don't follow that. But yeah. Otherwise, let me just look at layout as a whole too. So it's weird having your majority of your pores on the bottom side. That's completely opposite of how I do it. That's a complete personal preference on a 2-layer board. It's just throwing me off. Why is this a pore? This is ground here. Input. But yeah, this is a really really clean 2-layer layout. I would say, yeah, minor modifications here if need be. Potentially mess with your heat dissipation. Yeah, so that's where, again, my rule of thumb is get rid of that, add a ground pour on both sides, and then add stitching vias everywhere you can. Fill up all of these pores. Whoops. And now you're getting heat dissipation and lowering your inductance throughout the entire board. My head is exploding, but I'm learning a lot. Well, that's a good thing. Okay. Trying to think. So Jeff, did you have any other questions? Again, I mean, it's a really clean layout. You're just definitely going to have to mess with your output because that definitely can cause some emissions issues, and potentially look at if there's any common mode currents, because those are the easiest to fix with a common mode choke. But if not, and it's differential, then it's tougher. No, that's great feedback. Thanks. Awesome. Okay. So now I don't really have that much time. I think there's like 1 or 2 more. Oh no, just one. It's the same guy. Okay. He sent me 2. I fixed the hierarchy. Escape. New download available. That's funny. Yeah, I'll do that in a second. Let me just look at this real quick. Okay, so those are all just connectors. Everybody be sure to hit that like button. Oh yeah, that would be fantastic. Also, check out Patreon. Also, I'm sure everyone here is in Discord, but if not, definitely join Discord. That is a massive @mega. There's your main power input, battery charger, VCC. Oh, crap. My bad. Hang on. I'll come back to that if I have some time. I knew there was one other design to review. Whoops. This is from Navek, who I'll never know how to pronounce. One day, maybe. I need to have, like, a better way to, like, manage everybody's who I'm going to be reviewing, because it gets, like, kind of overwhelming remembering which are which. Okay. Is it a KiCad project? Oh, it's a... Not KiCad 6? Oh, I opened it with the wrong KiCad. Okay, here we go. That was... Oh my gosh. I wasn't expecting this beast. Oh my gosh. Yeah, Navek, give me some insight on what you want me to look at here. We got a lot going on. So this is one where I would definitely have some hierarchical sheets. This is kind of a cluster. Mostly the PCB. Got it. Here. This is a schematic for charging module of 2 batteries. There will be 8 of these inside a 19-inch case. The PCBs are mounted vertically. A central device used to configure the modules. Obviously, it's glued together with software. The power of the box. Got it. Okay. Don't have much time left. I know, right? No, but this should have been like the second schematic or the second board I reviewed, so it's fine if it takes a little longer. I don't have anything interesting going on later anyway. So one thing, just looking... Oh, that's not a buck. Never mind. Oh. Yeah, but this not being a buck, you don't need a ferrite here. Fuse on the output. Where are your bucks? Oh, right here. What are these? So this is a simple switcher. So then what is this? Oh, that's what he said, a digital pot. Got it. I was so confused. So all this is doing is adjusting the pot right here. Got it. Okay. Great content. I'm glad you enjoy. So buck in, we've got decoupling here. Good. I would say if you're using ferrites on the inputs here, I would probably use ferrites instead on the buck input. But overall, it looks fine. Okay. Yeah, this is a beast of a schematic with it all on a single sheet. Okay, think I kind of have a feel for this, somewhat. We'll see when I look at the PCB. Oh, very, very pretty. Man, there's been a couple really, or I guess all of the designs really, the PCBs have been really good this time. I hate when it's like looking at a PCB and you're just like, you tried. So, and this is reference to, I guess, just kind of as a whole. So, like, doing a 2-layer PCB, like, this is the goal. Like, this is exactly how you want a 2-layer PCB to look. You have one layer which has essentially no traces on it. He has just the bare minimum here, but otherwise it's a complete ground pour, or your complete reference plane. Then the top layer has all of your main traces. So you basically have all the top traces referenced to that bottom layer. Perhaps your videos are helping people do better. We can only hope. So yeah, just super quick look. Fantastic job on this. So now here's where I get to be nitpicky because of how good of a layout this is. You want to start thinking about areas where you don't have to go to the bottom layer. So there is absolutely no reason why this needs to be on the bottom layer. Move that back to the top. Move this to the top, and obviously move all these others. And now you can take all of these traces and run them over here. Because are these important traces? SCK? No, it's just SPI. So yeah, routing that a little bit more convoluted isn't going to be an issue. So yeah, just route those there. So now you get rid of two big discontinuities in your pour. For this side, so now for these, you can kind of do something a little bit similar. Oh, come on. I really wish KiCad would get better at... Oh, that's an inductor. Oh. Oh, it's an inductor. Okay. Fair point. I would not run SPI under an inductor from a buck. Oh. Okay. Yeah, unless you can move this somewhere, I would keep it how you have it. Because, yeah, that inductor is going to be really, really noisy. But yeah, the name of the game, it's an LC filter after the buck. Oh. Oh, you have a double pull. Oh, no, then I would be fine. That's not going to be that noisy at all. That's not going to be an issue because this node isn't even that noisy. It is. I thought it was this inductor, which means you would be getting this node. This is the noisiest node there is with a buck, and you have a two-stage filter here. So no, I would go back to doing exactly what I said. But that's a massive inductor. I mean, I know you need it because you want it to be a lower impedance or a lower frequency, but man, these things are massive inductors today. So yeah, I would keep this, and then with this, what you can probably do is move this to the top layer, put a via here, move this one to the top layer, and now run these traces, keep them on the bottom. That probably actually doesn't help that much. Never mind. But what I'm doing with this is basically, again, with a two-layer board, is every area where you have a trace on the other side, you want to do everything in your power to not have them there. Again, I'm being very nitpicky. This is a really, really good layout, but anywhere you can, you always want to. And then more nitpicking, I'm always going to reduce this as much as possible so they're closer together. My router settings are all messed up on this computer. So what else to look at? Probably the bucks are the most exciting here. Oh, and just so people understand, the reason why he has this second inductor is on the output of a buck, especially depending on the control scheme that it's using. In order for it to regulate the output voltage, you have to have a certain amount of voltage ripple. So it spikes up, down, normally by, he says, 55. So 20 to 100 or 200 millivolts here. And if you're using something out here that you don't want to have that much ripple, you have to add a second inductor and do an LC filter. So this becomes less noisy compared to where this is. So the regulator can still sense that ripple, if that makes sense. Okay, so the buck is here. Yeah, these simple switchers are just a beast because the frequency is always really low. 500 hertz, that's not bad, or 500 kilohertz. The whole ground plane would be split. Oh, but duck the SPI on the bottom plane. Yeah, he'd not one of your expert suggestions there. I would. Why is my trait router all messed up here? Yeah, we definitely don't want to have that SPI on the bottom because that'll split half the ground pour in half. YouTube suggested this to me. It's great. Do I become a patron? So basically, patrons get first priority, but on this stream, there were 2 boards, I think, which weren't patrons. So if you want to join Patreon, by all means do it. But honestly, no. I mean, if there's time, I'll still review yours. Was just thinking just under that back trace. Yeah, that makes sense. But again, since this is the second stage inductor, it's not going to be noisy at all because it's it's going to be at the ballpark the same here. So what was I doing? Oh yeah, the inductor or the buck. So we've got our input caps. Where's our ground pour here? So keep in mind our ground loop keep in mind that the ground loop that we're really worried about on the input side is going to be in here, around, and then on the ground like this. So having the caps on this side makes them almost useless other than where it dives under your vias. So if possible, maybe move this up a little bit and try to make some room for these to rotate, but I get you don't have a ton of room. Maybe something like that and move this over. That's probably a little nitpicky. So what's that deal with the FAT 24? Oh, it's a pour. So when you fill it, you don't see it. Oh, I guess that's how. So that's how KiCad 6 shows pores. It'll still show the trace underneath it. That's ugly. I don't know why they do that. In KiCad 5, it would just fill that entire thing up. That's gonna drive me nuts having to make that perfect. Okay, so then that comes in. Then our switch node is here. Goes to our 2 side through our diode. Our loop is here. You can change the opacity, can you? Objects. Ah, very cool. So now it cleans it up. Okay, cool. Got it. Very cool. It wouldn't have been required to put a trace there in KiCad 6. The pour would have been enough. It's because you have it set to dim instead of... Oh, okay. So yeah, I guess that does the same thing. Yeah, so the buck looks really good. Again, I'm not a fan of these simple switchers just because inherently they make the layout kind of tough with just how big they are. But with that in mind, looks good. And I'm assuming the other one's going to be laid out basically the same. So yeah, this one you definitely want to flip some of these the capacitors to the other side to make that loop better, because here you've only got one on this side, and I know you have these vias, but that's added impedance having to go on to that via and then back over. So yeah, Navik, anything else specifically on this? Again, like as a whole, this is like an example layout of like how to do a 2-layer board. So another nitpicky thing here, don't do this. Don't have that there, and don't have all these connected traces, you want to do it, oh my gosh. You want to have them coming out like this, because when you go to solder this, because there's copper there, it's going to make all of these short, and it's actually, that violates IPC standards because you can't have a bridge, even if by design it's fine. So definitely get rid of those. Yeah, like all of these, you don't want to have that. So these you just have go out. And I get it's annoying and it takes a little bit of time, but you really do want to get into the habit of doing that. I'm kind of bad sometimes in forgetting. So you just do stuff like that. Same here. That's a MOSFET, that's fine. But I don't like acute pad entries, so I would move it something like that. Daniel, nice tip, thanks. I'm almost positive I have mentioned that on one of your designs in the past. I think you're conveniently forgetting that one. So yeah, here, again, I don't like acute trace entries, so it would be like that instead. These are traces, wanted to have them fat as possible. It's still, you got to keep in mind that all of that current is going through this size trace anyway. So if you just have it extended to this far, you're not adding any appreciable resistance. It's the same way that thermals work, even though they're skinny. But yeah, that's really it. Everything else looks really good. Sweet. So yeah, let me check Daniel's real fast. I remember if you had said it. Good thing I have every stream still saved, so we can go through like 30 hours of streams and prove one of us right. Okay. One more thing, input protection. Okay, no, I can pull that up real fast. I still have it open. I look forward to you providing a timestamp. So where is, while I download Daniel's new one, where is the I2C protection on the schematic? Oh, so there's no TVS diode or anything. But where is it? Oh, I2C right here. Okay, so the easiest and the quickest is just to throw... Oh, you have a series resistor. So that's one good protection method you can have. What I would do is, you can do two different ways. I would probably keep the resistor right here and then just throw, like we were talking about earlier, just a unidirectional TVS diode. You can get a two-way one, so it has two TVS diodes in the single package, and throw that down here. So the series resistor helps limit the amount of current that goes to the TVS diode. And nothing special. I2C is super slow, so you can have a pretty beefy, high capacitance TVS. It doesn't really matter much. But yeah, I mean, honestly, even having the series resistors here alone, that helps a lot. But yeah, just add some TVS diodes and you should be good. Okay, so what did... Remind me, Daniel, what did you want me to look at? Was it this or the glow plug? PMOS gate drivers. Okay, what about them? So gate to source voltage plus or minus 12 volts. Hang on, let me pull up this data sheet. And why are you doing it at a as a high side driver? Because you do run into stuff like this. Okay, yeah, so that can work as a high side. So this drive, this all looks good. So yeah, if this is 14 volts, it's going to blow this. I mean, your easiest way is to just use a MOSFET that has a plus or minus 20 volts on the gate side. That's fairly common, because other than that, you're not PWMing this, are you, Daniel? Because if not, you could use something like this with a diode to... Oh, you are pulsing it, so then that probably won't work. Then, yeah, I would probably just swap out to a different MOSFET that can do plus or minus 20. It's not really a design review, but I need to regulate 13.8 for aviary. It doesn't exceed. I don't really need a gate driver. I mean, Daniel, if I'm you, I would just drive this low side. I mean, low side driving makes everything like infinitely easier, and you can even tie in the low side to your shunt resistor if you want to, or you could use this as the shunt resistor depending on how accurate it needs to be. As for Bob, I mean, you're not going to be able to do that with an LDO, so you're going to have to use a buck. If it's too noisy, maybe check out the latest EMC review or EMC for Everyone video I did, because I went over that exact same thing and how to make the input side cleaner so it passes conducted emissions. There was a reason why I needed high side, but I don't remember anymore. Yeah, the way it basically works is like you should use low side unless you have a reason to use high side, and that's about it. Because your other issue here is, why wouldn't an LDO work? Because he's going to be dissipating a metric crap ton of power. Like, what is that? I could be wrong, but he said what? 13.8 minus 3.3. Eh, 2 watts. I mean, I guess as long as you have an LDO that can handle 2.1 watts, which is doable, you can. It depends on if you need like high efficiency. Since you're saying it's coming from 13.8, that's lithium iron phosphate, I think, right? Or I guess lithium ion battery, so it's battery powered, so you probably want some sort of efficiency. But if not, yeah, an LDO would work. Because of the voltage divider needs P channel. And ESP has a 12 volt tolerant input and pulls 250. You can still measure before the load. ESP dev kit. Yeah, I was going to say ESP32. You cannot put 12 volts directly through it. But yeah, the dev kit, that makes sense. It's for a car. Okay, yeah, I mean if you can use an LDO that can handle 2 watts, maybe put a heat sink on it, then sure, that works. And if you need something quick, I mean obviously that's going to be a safer bet. I'll just switch it to low side. Yeah, that's definitely what I would do. And then you can keep doing how all of your other stuff is also and just copy this because that's definitely the easier way. All right. Well, cool. On that note, I think I will call it a day. So yeah, I think I'm going to start using or start doing a lot more streams just because I'm realizing with how busy we are, it's getting really hard to do videos consistently, especially like the EMC videos. I mean, they take like 30, 40, 50 hours sometimes, and I just don't have the time to do that right now. But these streams are super easy and kind of relaxed. So, oh, the Reddit post. Thank you for reminding me. So, yeah, if you guys have some suggestions and stuff on what you would want to do for streams, definitely let me know because I think I'm going to focus more on those. And let me find the Reddit post. Give me a couple of minutes. Thank you. I'll do that for now and reset my buck for the reason after this. Stream's good. Yeah, just give me ideas on what you guys want me to do. Well, remember the Renesys, their plant went down, and they made a crap ton of 485s. So that's probably one reason why they're more expensive. Okay, come on, where is it? Is there a way to search your own Reddit posts? I just have bought, alright, yeah. That's what's sad, you're literally having to buy breakout boards. Okay, I do not know if I'm going to be able to find it because it doesn't look like Reddit lets me search my last posts. Oh, that works. Okay, that's what I was just going to try. Reddit, username, comments. Okay, Yeah, I found how you can search it. Ahid, you were pretty close. Okay, yeah, I'm not finding it. Yeah, I can post in the Discord a little bit later when I find it. But sweet, yeah. So definitely, guys, let me know if you have any thoughts for like next streams or what I should do, because I think, like I said, that's what I'm gonna focus on a little bit more. But I really appreciate everyone who tuned in, and I will see everyone in the next stream. Have a good one, guys.